In this video, we're going to talk about Boyle's Law. So the learning competency is to use the gas laws to determine pressure, volume, or temperature of a gas under certain conditions of change. Okay, let's start. So given this graph, as you can see, as the volume increases, the pressure decreases. Mathematically, we can have this. Volume is inversely proportional to its pressure, where temperature and the number of gas are constant. We can also say that PV is equal to C, where C is a constant depending on the amount of gas at the given temperature. So again, this is only true if the temperature and amount are held constant. So we can have this formula P1V1 is equal to P2V2. P1 and V1 stand for the initial pressure and volume. P2 and V2 stand for the final pressure and volume. Boyle's law is best described by this animation. The trapped air acted much like a spring, exerting a force opposing its compression. Boyle called this effect as the spring of the air. Let's try to solve some problems. Okay.
I lost all hope today.
A gas confined to a volume of 1 liter at a pressure of 20 atmospheres is allowed to flow into a 12-liter container by opening the valve that connects the two containers. What is the pressure of the gas? It sounds so complicated, right?
Yes.
So since this is a Boyle's law problem, let's just use this formula right away. So we have the given initial pressure and volume, 20 atmospheres, at 1 liter. Now the final volume is 13 liters. Where did it come from? So again, there are two containers that are connected. When you open the valve, it connects, right? So the final volume will be 13. Then the unknown is the final pressure. It says there, what is the final pressure? So we're looking for P2. Now using the formula, just substitute everything. 20 atmosphere times 1 liter is equal to P2 times 13 liter. So manipulating the formula, we will have this 20 atmosphere times liter divided by 13 liters. So doing the math, we'll have 1.54 atmosphere. So let's not consider the significant figures this time, okay? So I just want to show you how to do it. Now let's have a harder problem. Okay. Okay. So a particular balloon is designed by its manufacturer to be inflated to a volume of no more than 2.50 liters. If the balloon is filled with 2.0 liters of helium at sea level and rises to an altitude at which the boiling temperature of water is only 88.0 degrees Celsius, will the balloon burst? It's, it's a difficult problem.
Why are you crying?
Okay, let's analyze the problem. It says here that the volume should be no more than 2.50 liters. So this means that if the volume of the balloon exceeds 2.50 liters, the balloon will burst. Okay, that's the maximum. If the balloon is filled with 2.0 liters of helium at sea level, and we've established that at sea level, the atmosphere is 101.3 kPa, temperature is only 88.0 degrees Celsius, we want to find out if the balloon will burst. Okay, so to do that, we have to determine the initial temperature. But there's no way that we can determine the initial temperature. However, we know that at sea level, the boiling point of water is 100 degrees Celsius. Knowing that, we can identify the pressure required for water to boil at 88 degrees Celsius. So we will have this ratio 100 degrees Celsius is to 101.3 kPa and 88 degrees Celsius times x, since we're looking for the pressure, right?
I don't know.
So we can write it like this. So 100 over 101.3. So manipulating this using simple algebra, we'll have x is equal to 101.3 times 88 over 100. Basically, it's just cross multiplication. X, which is the pressure, is equal to 89.144 kilopascal. And now we can use the Boyle's law to identify the volume, since it's the volume which dictates if the balloon will burst or not. So putting the numbers, we'll have this 101.3 times 2 is equal to 89.144 times the volume. Okay, so solving for the volume, we'll have 2.27 liters. And since 2.27 liters is less than 2.5, we can say that the balloon will not burst. Okay, so note that I didn't round off here. You round off in the final answer. So let's have a harder problem.
Ooh, a lot of people will be scared here. A lot of people will be scared, and I'll name them.
So two bulbs of different volumes are separated by a valve. The valve between 2.0 liter bulb, in which the gas pressure is 1 atmosphere, and the 3.0 bulb, in which the gas pressure is 150 atmosphere, is opened. What is the final pressure in the two bulbs when the temperature is constant and the same in both bulbs? Let's dissect the problem, okay? So we know that there are two bulbs of different volumes, and it is separated by a valve. First bulb is 2.0 liter at 1 atmosphere, and the second bulb is 3.0 at 1.50 atmosphere. So we're looking for the final pressure when the bulb is opened. So let's start with the formula P1V1 is equal to P2V2. Solve for bulb 1 first. Using the values from bulb 1, we can calculate the pressure, right? So P2 is equal to 1 times 2 over 5. And we will get 0.400 atmosphere. Now solving for bulb 2, we will have this equation 1.5 atmospheres times 3 liters is equal to P2 times 5 liters. So manipulating the formula, we will have this, and solving for pressure, we will have 0.900 atmospheres. Since the valve will be opened, there will be a final pressure, and to get that, we have to add these two individual pressures. So the final pressure will be 1.30 atmospheres. Three significant figures, since in the given, you have three significant figures. So again, to summarize, Boyle's law is the relationship between pressure and volume. Temperature and the amount of gas are constant. Mathematically, we can say that volume is inversely proportional to pressure. And we have this formula P1V1 is equal to P2V2. Okay, so we use this when the pressure or volume changed.
Hey, that's pretty good.